This is the first step towards our Fruit Ninja clone. Fruits launch from different parts of the screen, follow different trajectories, and disappear once they leave the play area. And because we are using physics, we don't need to manually calculate their movement. Let's build this from scratch. Let's start with the most important object in our game, our fruit. So for our fruit, I would select a rigid body 2D as it already has built-in Godot physics to it. I would then rename it as fruit and I would add sprite to it. Inside sprite, I would add an apple image to it and I would add collision for its physics. The collision could be roughly equal to the apple size, it doesn't need to fit exactly, so I would use a circle shape and fit it roughly. There, it's done. And that is our fruit scene for now. Now let's create our main scene. I would use a 2D scene here and name it as main. Before creating our spawning system, I would like to just add the fruit and check if it's working properly. So I would pull it somewhere here and I would run the scene. Run and save. You can see the apple fell down even though we didn't code anything for it. This is because we already used rigid body for it. Obviously we don't want our fruit to just fall down. We want it to be thrown in air. Since we are already using rigid body 2D, we can simply give it an initial velocity. So I'll go back to the fruit scene, I would add a script to it, and inside the ready function, I would set its linear velocity as something like vector 2, 150, comma, minus 800. So we are giving it a push little bit to the x direction and little more in the y direction. If I go ahead and run the scene, you can see it moves upward in a projectile. Let's also make the fruit rotate while it's flying. Rigid body gives us angular velocity for this, so let's just set it. Angular velocity equal to randef minus 5 comma minus. So what this tells is angular velocity would be set from somewhere between minus 5 to plus 5. And now if I run the scene, you can see the apple is spinning and moving. Now let's spawn them using our script. So I would go to the main scene and I would add a script. I would also delete this fruit since we are spawning it automatically. I would add a variable called fruit scene where I would preload. So our fruit.tscn gets loaded here and then I would write a function to spawn fruit. New fruit equal to fruit scene dot instantiate. This basically instantiates an instance of our fruit scene in the new fruit variable. Then I can just add it as a child to our main scene. We also need to set its position. So for now, I would set it to some position. I would set it to something like 500, comma 400, and if we run the scene, nothing would happen because we are not calling it anywhere. So let's just call it from our ready function. And now if I run the scene, oh, we need to set the position to the new fruit and run the scene. And you can see our apple is spawning and launching. But we just don't want a single apple, we want multiple of them to be spawning. So what we can do is we can just add a timer. We could set the auto start to on and inside signals we can just add the timeout. So if we connect the timeout signal, you can see a function here appears and we could just call our spawn fruit inside it. So what happens is every 1 second it would call our spawn fruit function. If I run the scene now, You can see after every 1 second a new apple is spawned. Its rotation varies a bit, but its trajectory remains the same because we coded for that. There is another issue that all the fruits come from exactly the same position, which gets repetitive very quickly. So we need different places for our fruits to start from. Instead of hard coding positions, let's create a few markers. I'll add a node 2D and I'd rename it as spawn markers. This is just to organize our marker nodes. Then I would add our marker nodes and I'd duplicate it. Then I would place the marker nodes one on the right side, one on the left side, and the last one at the bottom. These markers don't actually create anything, they are simply points in the world that tell us where we want our fruits to start. Now we need our code to randomly choose one of the marker as the position. To do this, what we'll do is we'd add a variable to our spawn fruit called markers and set its value to spawn markers dot get children. What this does is it gets all the children of the spawn markers, that is all the markers that we have. Then we can simply write marker dot pick random. I would rename this as markers and var marker equal to markers dot pick random. So we got all the markers, we picked one on random, and now we can use the position of this marker as our spawning position. Now if I run the scene, you can see the apple is flying from the different spawn positions that we assigned. Now you can see it feels kind of weird because this apple spawns and goes right off the screen. This apple looks like a good direction and this apple goes out of the screen as well. So we need to set its linear velocity according to the marker that we selected. Let's stop it and go back to our scene. Now let's go back to our fruit scene and you can see this happens because our linear velocity is being set here as a fixed value. What I want to do instead is set its linear velocity from somewhere outside like our main scene. So instead of calling this all in ready function, I would just rename it as launch and it would take an input parameter called direction, which would be a vector 2. Now this direction would be our linear velocity. Now we can simply go to our main function and after we have set the position, we can just define a variable called direction and let's initialize it as 0 and we could just call new fruit dot launch direction. So it would call the function and as we are setting the velocity as 0, all the fruits should directly fall as they don't have any velocity. Seems like it's working. So now let's set the velocities depending on which marker it is spawning on. So for this marker, I would rename it as left. I would rename this marker as bottom and this marker as right. Once that is done, I would go back to our script, match marker.name. So I'm matching the markers based on name. So if the marker's name is left, what I want is the direction to be vector 2 dot 250 comma minus 800. Then if it is bottom, the direction would be 0 comma minus 800 and if it's right the direction would be minus 250 comma minus 800. So we have set a direction for every marker name. And if we add a new marker whose direction is not present here, then it would be set to 0 by default. So if I try to run the scene, you can see our fruits make much more sense right now. And did you see the issue? One of the fruit just collided with other fruit. We don't really want this, so we would fix this as well. The other issue is that even though they're spawning based on the marker, it's quite predictable. This will go up, this will go in this projectile, this will go in this projectile. So we want some randomness, and we also need to solve this collision problem between our fruits. So let's first solve the randomization problem. Currently, we are setting the directions as some fixed values even though it's based on markers. So let's just make it a bit more random. So direction.x plus equal to, this would add some value to the direction of x. I would also add some to direction.y. I would not make a heavy change to y because it affects the height a bit. So I would do it 50, 50. And if I run the scene, we should see it much more random now. Oh, I think I did X in both places. So I would just do Y here and I would run it again. You can see each of the apples slightly deviates the path. Okay, now we need to solve the collision problem. The apples colliding between themselves. So if I go to the fruit scene and you go down here in collisions, you can see there are two options, layers and masks. So what this simply mean is that the layer is on what layer you are, and mask is on what layers would you collide with. So the fruits are on layer 1, which is fine, but I don't want the fruits to be colliding with other fruits, so I would turn this off. And if I run the scene, the fruits should no longer collide. You see the fruits are passing through each other and just spawning. Now if I want to make the spawning faster, I could just go back to our main scene and reduce the time to something like zero point 0.5. So a lot more of the fruits would be spawned. Now this looks all great and fine, but if you go and see here in remote, you can see all the fruits that we spawned still remains, which could be a huge performance issue later on, as the fruits just keep piling on as long as we keep spawning them. So once the fruits exit our visual area, I need to just remove them. And we also need to reduce our y velocity on upward direction, as the fruits tend to go out of the screen in the y direction as well. So first thing I would do is reduce the y velocity for these two. Then I would go to our fruit scene and I would add a visible on screen notifier 2D. This node can tell us when the object has left the visible area. So I would first expand it. I would intentionally keep it a bit bigger, so even if it goes out of the screen on the top side, it doesn't matter a lot. And then in signals, I would connect the screen exited to it and connect. So when our fruit exits the screen, which is this area, our signal would be emitted. So what we do on this signal? A simple cue free, nothing much. We just remove the fruit from our scene. That's it. And if I run the scene again, you can see the fruits keep spawning, but not a lot of fruits stay in here. This is because once they are out of the screen, they gets removed. Also notice that we reduce the velocity of y on the left and right. So now it looks pretty neat that all of them are just bunching up. One final thing I would add before ending today is add a background node to it. So I would go back to our main scene. I would add a child, a canvas layer for all our UI purposes, and on the canvas layer I would add a texture rect. I would set it to fit the entire screen, and I would set my background node here, and I would make it ignore the size. I would also go here in the ordering and set its z index to -1 so it renders below everything. Actually, I would do it the same for the canvas layer as well. And now if I run the scene, it should look pretty much better. And that's our spawning system. We created a physical fruit, we gave it natural trajectory using rigid body 2D, we stopped fruits from colliding with each other, we created them dynamically, we automated spawning with timer, we added spawn markers so fruits can enter from different positions. We made their launch direction depend on where they spawn. And finally, we automatically remove them once they leave the screen. In the next episode, we are going to build the swipe system and finally give the player a way to interact with these fruits. If you like this video, be sure to like it and subscribe. See you in the next one.